Hi, how are you all doing today? Welcome back to Emoji Economics YouTube channel. Um, yeah, I've figured that there are students who don't understand graphs. Yeah, and then they are studying economics. Like wow. Yeah. So in economics, you have to deal with graphs a lot. There is something about shifting demand, shifting supply, movement along the demand curve, whatever. Then you go into things like national equilibrium, you'll be shifting this graph, you'll be shifting that line, and like some of you are just like, what are all of these things? So and then that's why we're having this class, right? Now, basically speaking, what I wanted this class to be about was graph, like teach you how to like sketch graphs properly, what are things that you're supposed to know. But while preparing for the class, I began to delve into like different things, the way I could be sometimes. So I want to like generally call this class an introduction to mathematical economics because I'll be speaking about some other things, besides graph. It's around graphs and other things, other related things. Yeah. So with that, then what is a graph? What is a graph? So basically speaking, a graph is a diagrammatic, representation of the relationship between two or more variables. All right. A graph is a diagrammatic representation of the relationship between two or more variables. You must have seen a graph before. Like there is no how you wouldn't have seen a graph before. So you have this is an example of a graph. So let me tell you the rules of a graph now. There is something that we call zero here. This is the origin. So whenever you are drawing any graph, right, the origin should be there, right? And then you have this is called the x-axis. This is called the y-axis. Then you might have a line inside of it, right? And then you may not have a straight line like this. You might have a curve inside of it, like in the case of a total cost curve. Yeah. So you label this appropriately. So if this were a total cost curve, for example, right? So it is a curve showing the cost incurred as production takes place, right? So the production is represented as output or quantity, and then you're going to label this place as cost, then zero. You understand? So this does not have a particular title. The first graph I drew does not have a particular title, right? It's just like that, but it is a straight line, yeah. And this is not a straight line. All right. So if you look at this now, this is since we are talking about economics, right? So what kind of graph do you have that might be upward sloping? So a very easy example is supply curve. Yeah. So you just name this guy the supply curve. And for supply, what you have here is price, and what you have here is quantity. So which means your x-axis is showing your quantity, then your y-axis is showing your price. Yeah. So again, a graph is a diagrammatic representation of the relationship between two or more variables. Between two or more variables. So in the one that we've done here, we only have two variables. What are they? Price and then quantity for the first one, which we use to like sketch our supply curve. This is going to be quantity supplied, since we are talking about supply. And then here we have cost and then we have output, right? So this curve that is there is actually your total cost curve. You are going to be learning these things, as you progress in your academics or in your economics journey. So this is TC, right? So you kind of put it there. So where TC is the total cost. So I could just name this in full and call it total cost, but I could still leave it as cost. Yeah. So there are cases where graphs would not show relationship between just two variables. It can be more than two variables. Like there was one that I drew and I sketched, all right, in one of our classes yesterday, looking at the relationship between marginal utility and total utility. So right on that graph, we had to sketch, we had how many variables? Um, we had quantity was a variable, then we had marginal utility was a variable, and then we had total utility as another variable. So these were three variables that we were trying to like estimate, that we're trying to like show the relationship between them on the same graph. You understand? So in that case, you are looking at relationship between three variables, right? So then, what is a variable? Like these guys been talking about variables all this. Like, what is even a variable? Yeah. So a variable is a measure that can take on any value. A variable is a measure that can take on any value. Yeah. So it's not difficult. Or a variable is an alphabet, right, that has an unknown number. A variable is an alphabet that has an unknown number. I'll just say a variable is a measure that can take on any value. And then all around us, you have variables. Yeah. So my age. So age is a variable. Your age is a variable. Time is a variable, right? So like anything can be a variable. The number of times that you're attending this class, that you're watching this video, could also represent a variable, right? So scores, those are variables. So how many classes do you have in a particular school? So class in that case could be a variable. So like every life is, you are just looking at a measure, right? That can take on any number, right? So now is there okay, so it's the same that I have here. I was trying to see if there's something that I've missed out, right? An alphabet that has an unknown value, right? So or a term with an unknown value or an unknown quantity, because variables, you won't put a number first. So like here now, this is price. So it's not as a price as so it's not as a price as a number yet. So but since you've identified a variable as price, so price may now begin to like be different numbers. So price, then when price is 2 naira, so price is assuming a number that is two, right? Now when price is 5 naira, price is assuming a number that is five. When price is 200 naira, price is assuming a number that is 200, right? So the price there is the variable which can take on, different quantities or different numbers here. So now we now have two types of variables, basically speaking. So we have one that we call the independent variable. So for every equation or for every function, we are going to be having at least one independent variable or a set of independent variables. Right. So we have independent variable. So this is not a variable that is independent. So please don't define it that way. Then the second one is the dependent variable. Dependent variable. All right. So what is an independent variable? An independent variable is a variable whose value is not determined within a model, right? An independent variable is a variable whose value is not determined within a model, right? That is, you get the value outside the model, you get the value from somewhere else. Then you now begin to think, what is a model, for God's sake? This guy is trying to simplify a variable, but then he's mentioning something that I don't even know. All right, so a model is an abstraction of real life. A model is an abstraction of real life, or a model is a simplified reality. A simplified reality. So a model is basically a function, a mathematical function that tries to explain, the changes in a dependent variable based on identified factors, right? Based on identified factors. So what I'm trying to say now is, for example, if you were to buy something, right? So that's we are looking at your quantity demanded. If you want to buy something, what are some of the things that you're going to be considering to buy that thing? Okay, you can say, oh wow, price. Yeah, sure. That's the first thing that comes to mind. Price. So you can have so we can have price. So what this is going to be a function of price, right? It's going to be a function of what else do you think? How about your taste? Yeah, a function of taste. Well, if I like the products, I get more of it. If I don't like it, all of those things. Then after taste, then you look at my income. Do you understand? Then what about convenience? How convenient is it for me to buy it? Then you have weather, in case it is a seasonal product, maybe like umbrellas and all of that. Or then you have season, right? Season. Okay, maybe it's a Christmas time or Ramadan time and all of those things. And then price of a related commodity. Price of a related commodity. So let's say you want to buy a phone, you want to buy a techno phone, and then you are kind of in trying to like check if you are to buy this phone or not. Then there is Samsung, their alternative. So you look at their qualities, you look at their prices, and that can influence your choice of the demand for a phone. So like if you look at it, there are so many factors, and there are even some that are probably in your mind now that you are not, that you are probably saying, I can't hear you anyways, but you're probably saying that I've not even included here. Do you understand? So factors affecting demand, yeah, they can be so many depending on the agent that is talking about, depending on the individual concerned, or depending on the business or whatever that is, looking at, what should determine its demand for a particular product. So what a model does is, how many variables have we identified? One, two, three, four, five, six, seven, seven, and others. So a model will now say, okay, try to like factor in all of these things in the explanation of what is going to happen to quantity demand, then why not just pick one variable, right? So a model, this is a model, right? This is already a model, right? Then a simplified one will now be, okay, QD is a function of price. Do you understand? And here you will now have QD equals maybe 100 minus 2P. So this has limited quantity demanded to only being a function of the price of the commodity. So this is a simplified reality. Do you understand what I'm trying to say now? This can also be this. In fact, this is also a model, right? But usually models are not this long. Do you understand? You can't like when we say model is a simplified reality, it is simply because you can't just possibly factor in every possible factor that is determining, what you are trying to look at. So you can't just, it's kind of impossible. You understand? Because some are impossible, like some things they are impossible, and then some things are immeasurable, right? Okay, how do I measure convenience? Because for me to use a model, then that means because this is a mathematical model, for me to use a model, then that means I need to like be able to express all of these variables, right, in terms of in quantitative terms. So how do I quantify convenience, for example? So if you cannot quantify convenience, then that means you kind of have to like, accept it from the model. You understand? And then there are cases where if you were to run a model, work with a model like this is like cumbersome. Yeah. So like just pick the very important ones or the ones that you are really interested in talking about, which is like, okay, I want to look at the implication of the price of a particular product on the quantity demanded. Yeah. So or if you want to like make it a little bit elaborate, so I can just say quantity demanded is a function of my price and a function of my income, right? Actually, this is very important here. So you have QD equals, let's say you have 250 minus 3P, then plus 0.4Y. Okay, so here you want to work with um price, and then you want to work with your income. So like you don't just want to deal with the whole thing there. So again, a model is a simplified reality, right? So a model contains, a set of variables that try to explain, the changes in the dependent variable. So I was talking about independent and dependent variables. So if you look at here now, you have two variables here. You have the price of the product, and then you have the quantity demanded. So when we come to this place, we have three variables. We have the quantity demanded, the price of the product itself, and then consumer's income, right? So if you look at it, the one here on your right hand side here, so these are called independent variables. Why? Their values, like you just give them random values. Do you understand? But like, you don't give QD random values. So let's start with this. So whatever value your quantity demanded is going to be depends on the price of the commodity. So, and if you remember the law of demand, it states that, what does it state? The higher the price, the lower the quantity demanded, right? And then the lower the price, the higher the quantity demanded, and vice versa. So, which means it is price that moves first before quantity demanded moves. Yeah. So, because price is the like first mover or something like that, so price is going to be our independent variable. So, whatever QD is going to be is now a function of that price, right? So, QD is depending on the value of price. So that's why we call QD the dependent variable. QD is depending on the value of price. QD is the dependent variable, but price in this case is not depending on anything. So that's why we said that the value that price is going to take is not determined within this model, right? So for example, if I say let P equals 4, that's just the way it's going to be, like for real. Let P equals 4. How did you get 4? No, just let P equals 4. So with that, what is QD? So QD will be 100 minus 2 into bracket 4. So that's QD equals 92. So you see now that the value of QD depended on the value of price. Hope you get it. So an independent variable is a variable whose value is not determined within the model, right? And then a dependent variable is a variable whose value is determined within the model. So it's as simple as that. QD is a dependent variable, its value is determined within the model. Now, this long model that we have here, if you're asked how many variables does this model have? One, two, three, four, five, six, seven. Seven? No. Plus QD, that's eight, right? So how many dependent variables do you have? You have only one, which is your QD. The rest of them are independent variables. Now, the function here is not a variable. It is just telling you that whatever the value of QD is going to be is a function, right? Depends on the values that all of this, take. That's the job of f function. Yeah. So I believe that is settled. Now, the set of values that your independent variable can take. So you see now that it's like I'm deviating away from graph or whatever. So that's why I just let's call the class Introduction to Mathematical Economics. Yeah. So I've defined a model for you in this class. We've spoken about dependent and independent variables. Yeah. So the next one that I want to go to is the set of values that your dependent variable can take is called something. Yeah. If you remember here, we had from this simplified version. So let me say I just have this. We have P and then we have Q. So P, when the price is 0, the price is 1, 2, 3, and then let's say 10. So what will be the values of your Q? Now, if you let's work with this function. Let's work with this one. Okay, so if you work with that, when P is 0, just put 0 here. When P is 0, 2 times 0 is 0, then Q is going to be 100. Yeah, when P is 1, Q is going to be 100 minus, that's 98. When P is 2, this is 4, this will give us 96. When P is 3, 2 times 3 is 6, 100 minus 6, that's 94. And then when P is 10, 2 times 10 is 20, 100 minus 20 is 80. 80. Yeah, so this, like I said, is the um, independent variable, and then this is the dependent variable. Yeah, because price is what is determining quantity. So like this set of values that this guy is taking, all of these values here, they are called something, and then all of these values are also called something. So all of the values that the independent variable is taking, so all of the values that your independent variable is taking is called the domain. This is called the domain. And then all the values that the dependent variable is taking now is called the range. So all the values that the um, independent variable is taking, they are called the domain, and the corresponding values of the dependent variable, they are called the range. So in case you see something like this in an objective question. That's being said, so what then is the next thing? Let's continue to work with this. Let's continue to work with that. So I think, so when you have QD, and you have QD equals 100 minus 2P. Okay. So what you have here, what you have, this 100 is the intercept. So by the time we are trying to use this to draw a graph, this is going to be the intercept. That is where our graph is going to be starting from. And then these two that you have in this place is called coefficient. Coefficient. Coefficient is a number beside a variable. Number beside a variable. Coefficient is the number beside a variable, right? So whether it is beside a dependent variable or beside the independent variable, right? So just note that. Then 100 is the intercept. It is also called the constant term. The constant term. Why do we call it the constant term? It's simply because um, when price, for example, here is 0, if price is 0, QD is 100. So that's just it. When there is no price at all, when there is no price on the product, quantity demanded is 100. So to tell you that something else is determining the quantity demanded of this product, besides the price of the product. Yeah. So when price is 0, maybe the product is free, and I don't know. So quantity demand. So 100 is not changed; it's just fixed there. So we call it the constant term. It is not as a function of price. So 100 is not as a function of your independent variable. It does not change. So whatever value P likes that it takes, your 100 does not change. It's just like that. So but then QD will be changing with the value of P, and then the value of P in addition to 100, those will affect the QD that you have there. So what if our equation had been expressed as this? What if it had been expressed in this form? QD equals A minus BP. So A does not have a number, B does not have a number, and P does not have a number, right? So what does that mean? QD is still the dependent variable, yeah. P is still the independent variable. A is what we call the constant term, right? So in this case, A is the constant parameter. So when the parameter is yet to, when the alphabet, right, which is not a variable, well, it's not a variable, P is the variable, yeah. So when the alphabet is yet to take a number, right, so we call it a parameter. So this is the constant parameter, and then this is, the slope parameter. You understand? You can just, there are parameters, two of them are parameters. A is a parameter, B is a parameter, right? So, but by the time we want to look for the slope of the demand curve, for example, what we are going to be left with is B, right? If you remember from your mathematics in school, so when you are estimating a linear equation, so you have y equals mx plus c. So c is standing alone. So in this case, A is the same as c. They are both constant terms. Like C does not have anything. Now this X here is the independent variable, and P, the independent variable, is having the same function as this MX. M is the slope, right? So M, which is the slope, is the same thing as B. But in this case, this is a plus M, even though we don't put a plus beside of it, and then this is a minus B. So we are just saying that the slope term, M represents slope when you estimate a linear function like this. So you have M equals minus B. So minus B is your slope in this demand function. So that's what I'm just trying to tell you. Although we are still going to do mathematical calculations on slopes for you to know how to get a slope. And that's being said, so what else do I want to talk about? Yeah, when you have a straight line, when your graphs gives you a straight line, your curve is linear. When your graph gives you a straight line, your curve is linear. So whether the line is like this, let me draw others. And so I was trying to talk about linear graphs. So whenever you have a straight line, like I said, you have a linear graph. So if your graph is like this, it is linear. If your graph is like this, it is still linear. If your graph is like this, it is still linear as long as it's a straight line. Yeah, so your graph is linear. So just in case, right? So how do you know a linear graph from a linear function, right? So what if you have a function? Now let's say the example that we're using, QD equals 100 minus 4p, for example. So what you just have to do is like look at the power, right? What is the power? What is the highest power here on the variables? You have two variables. So what is the highest power on the variable? On the variables, one. The power here is one. The power here is one. Yeah. So by the time you are sketching this graph, it's going to be a linear graph. It's going to be a linear graph. Yeah, it's going to be a straight line. So that's what I'm saying. Now this is, all of these things, they belong to a function in mathematics that we call polynomials. So, but here the polynomial is raised to power one. Like it's not yet a poly anyway. Understand? But like this equation now is raised power, so like it's a polynomial of 1 degree, right? 1 degree polynomial. Like that's what this guy is here because the highest power of the variable is one. So um what if you have this, for example? I don't know. You guys are used to something like, you must be used to something like ax squared plus bx plus c equals 0. Ax squared plus bx. So this is a second degree polynomial, right? So how do you use a second degree polynomial? You look at it. What is the highest power? So the power is also called exponent, right? Exponent. So what's the highest power of the independent variable? Obviously, the independent variable here is x, right? So what's the highest power of the independent variable here? So we have 2. Yeah. So this is a second degree polynomial, which is also known as a quadratic function. So because this has 2 on it, by the time you are drawing its own graph, so it's going to have a turning point. Now, this is what I mean. Instead of it to be a straight line, it will likely be something like this, or it's going to be something like this. So it will have just one turning point. Now, because this one, the highest power is 1, it has zero turning point. That is no turning point at all. That's why it is just a straight line. So this one is raised to power 2, which tells that okay, there's going to be just one turning point. So what if it was a 3? So what if we had ax squared plus b as cubed plus bx squared plus cx and plus d equals 0. This is a third degree polynomial. Third degree polynomial because the highest power of this function is 3, right? So by the time you are drawing the curve of a third degree polynomial, by the time you are drawing the graph of a third degree polynomial, it is going to have how many turning points? 2. So it's as if the turning points are like -1 of the highest power of the polynomial function. So since the highest power in the polynomial function here is 3, this is 2, this is 1, and this is the x here is 0. So that's why it is not there. Anything raised to power 0 will give you 1, right? So x here is 0. So like if you have dx raised to power 0, x raised to power 0 becomes 1, right? So d multiplied by 1 is just d. So you just have this one here. And so if you were to draw this graph, for example, it can be something like this. It can be something like this. This is a turning point, then it turns again. So it turns here, it turns here, so it's turning twice, right? So it's not necessarily always like that. What if it might be coming down? So let's say it can be something like this. I'm thinking of how to draw this thing. So let's say there's something like this. It's on there. Do you understand? So you are going like this. There's a turning point here. There's a turning point here. These two turning points, there's a turning point here. There's a turning point like you're moving, and then something happens. You turn. You understand? You don't necessarily. For me, I've turned back to where I was coming from, but it's not necessarily like that. So I'm going like this and then turn like this or turn like this. Yeah. So that's what we are. So that's enough turning point. So like you will just know from your equation you're going to know. And then one rule about polynomial is that and it's just conventional, right? That when you're writing a polynomial equation, what you just do is that you ensure that the highest power is the first part, the first term of the equation. This one is 3, then followed by the next one, power 2, then power 1. Then here it is actually power 0. So I said here that place x raised power 0, that's what you have. N raised power 0 is 1. You can use your calculator. 5 raised power 0 will give you 1. 1 million raised power 0 will give you 1. Yeah. So here x raised power 0 has become 1. So d multiplied by 1 is d. So that's why you don't have anything like x there. So conventionally, just like write it like this. Yeah. So like I think that settles that. So what is a polynomial normally? So a polynomial is a function with positive powers of the variables. A polynomial is a function with positive powers of the positive. So 3 is a positive number, 2 is a positive number, 1 is a positive number. Do you understand? Yeah. So here you are not going to have 0 anyway because it's stands as a constant term. And then here too, 2 is a positive number, then the power here is 1 positive number. So like you get it now. So a polynomial function is a function whose variables have positive powers. Yeah. So like that's about that. Then I think this class is already getting longer and I don't want us to spend more than what we are supposed to spend. So how do we get the slope of a function? So I've spoken about linear curves, I've spoken about non-linear curves and how you can know from your equations if you have linear curves or non-linear curves. And then okay, one thing that I should also tell you is that for linear curves, for example, this okay, we'll calculate slope now anyway. So let's go to slope. So this is how you calculate your slope. Just draw like bring a triangle out. So for linear curves, it does not matter where you calculate your slope. The slope is constant. So if we use this calculator as slope, it's going to be the number here will be same as number here, will be same as number here, will be same as if you had used the entire line to calculate a slope. The slope, if you had used the entire line like this to calculate the slope, it is still going to be the same thing. But it is not so for curves like this. The slope in this place, for example, the slope here, this is a flat line. So the slope of a flat line is 0. So the slope here is 0. Now it was upward, this from this region like this upward, it was upward sloping. This is going to have a positive slope. This is a 0 slope, and this is going to have a negative slope because the line is already coming down. So like for curves, they have different slopes in different region, depends on the region that you're looking at. Yeah. So if you look at this, initially this is a gentle slope, this is a gentle slope. So like coming like this, you have a slope here. So it's going to be a positive slope anyway, but it's going to be small. Then coming to like this part, the slope here, the line here has become steeper. Okay, more dangerous than the line in this place. It's still a positive slope, but then it's going to have a different number. So this one can be like plus 0.75, this one can be plus 0.3, right? So for course, the slopes are different depending on what you're looking at. So and then the slope of a flat line is zero. This line is zero. So I'm going to stop. I think we should just stop there. We'll just calculate the slope. I wanted to like talk about shift and movement, but then we are running out of time. So let's just look at how to calculate slopes. Yeah, I figured that the class is already too long already. So let's just stop here. We'll continue um with the rest of the discussion in the next class. Thank you very much for coming. I hope you enjoyed the class. If you have questions, of course, leave them in the comment section. Is there an assignment? Should I give you an assignment? Let me see. Is there anything here? Uh, okay. There's an assignment, types of graphs. Very simple stuff, right? So you can just put that in the comment section anyway. So like mention like 10 types of graphs. So we've spoken about graphs here. 10 types of graphs. Yeah. So that's like I think that's okay. Yeah, that's okay. So next class we are looking at slope, and then please remind me we are also looking at the features, the question. And yeah, I came across this textbook. I didn't write it anyway. Spotlights on economics for it's actually for secondary school students, A level, polytechnic, and universities. And to be very honest, I'm recommending it for students in 100 level basically. I've been going through the content of this book, and for God's sake this is more than what a high school student needs. I was looking at the King Demand Curve. Look at the theory of costs and all of very very interesting things. Look at things like this. Looking at the profit market, then and so on and so forth. So it's a really good book. Yeah, and that's why I'm recommending it. If not, I wouldn't recommend it. Look at the authors um, Oyenuga Adewale and Okonla Elisha. So this is not my name. My name is Olori Govin. So I just think as a 100 level student at least, you should get this book. It's not really very, no, it will not be like okay again when you're in 300 level and all of that. But then 100 and sorry level, like this book is really okay. It's more than what a high school student needs. And then if you're in high school, please just find a way around it. Just try to get it. Yeah, just I don't know. Just try to get it. So it is what it is. So that's that's about that. See you in the next class. Thank you very much. Have fun.